All right, so let's take a look at an example when we're solving right triangles in the coordinate plane. So this says that the coordinates of the vertices of triangle PQR are -3, 3, Q is 2, 3, and R is -3, -4. And so we are supposed to find the side lengths to the nearest hundredth and the angle measures to the nearest degree. All right, so again, let's maybe go back and just underline the information that we know, right? So we know the coordinates of the vertices, which is very helpful. We also know that we want the side lengths to the nearest hundredth and the angle measures to the nearest degree. Okay, this is all really important information. Okay, so I think the first thing we should look at here is plotting the points. Okay, so I'm going to plot these points in blue. Okay, we have -3 and 3, so I'll go 3 to the left and 3 up. Okay. On the next one here, I've got 2 and 3, so I'm going to go 2 to the right and 3 up. Okay, and on the last one here, I've got -3, -4, so I'm going to go 3 to the left and 1, 2, 3, 4 down. Right. So now that I have these, let's go ahead and maybe label the vertices. Right. So this was P. Okay. The second one here was Q. And the third one was R. Okay, and I'll go make, straightish lines here. Okay. Okay, that last one's kind of bothering me, so I'm gonna redo this just a little bit here. Okay, I know that's not perfectly straight, but I guess that'll do just fine. Okay. It wants everything, right? We're solving this triangle. Okay, so a couple things I might say right away is I might say angle, or the measure of angle P equals 90 degrees, okay? So we know that the measure of angle P here is 90 degrees because we have a vertical and horizontal line, right? So we can say something like, for our explanation, we can say that PR is perpendicular to segment PQ, okay, by definition, right? We know that vertical lines and horizontal lines are perpendicular. So that's definitely good to know, right? So we know that we're dealing with a right triangle here, okay? The next thing I might say, maybe I'll talk about my angle measures here, or my side lengths in green, right? So they're kind of nice to us here because we know that PQ is a horizontal segment, so we can just sort of say that this is 1, 2, 3, 4, 5 spaces, right? So we can say PQ, PQ is going to be equal to 5, right? And the next thing we can do is find PR, which would I guess sort of make sense here, right? So I can find out that this is going to be 1, 2, 3, 4, 5, 6, 7, right? So we now say that PR, oh, sorry, it's almost an RP. So we know that PR, on the right over here, PR equals 7, okay? And now we can go ahead and find this third side length, probably in a few different ways here. I could definitely use trig ratios, which might be kind of fun, and since that's what we're learning, maybe we can definitely do that. I need to use some inverses of trig ratios here to find some particular angle measures. So I could say, let's maybe look at this through the lens of angle R. Okay, so I'm going to say that let's see, if I'm looking at angle R here, again, I'm going to show my work in red. Okay, so if I'm looking at angle R, I want to look at the side lengths that I know if I really want to know that measure. So the side lengths I know here, again, are PQ. I know that this is 5, right? And PR is 7, right? So 7. It's a terrible 7. Let me fix that. Okay. So again, I know those two lengths, right? And it looks like that's going to be the opposite leg and the adjacent leg is what I have. Okay. So what I'm going to write here is I'm going to write the tangent. Again, we look at SOHCAHTOA. If I have opposite and adjacent, it's tangent, right? So I'm going to look at now the tangent of R is going to be equal to 5/7, right? And I know both of those side lengths, okay? And during this lesson, we learned that we can now find the measurement of angle R by saying now the measure of angle R is going to be equal to the the inverse tangent of 5/7, right? So now at this point we can go to our calculator here. Let me grab my calculator and I will type in 5 divided by 7. I'll type in that quotient first, and now I'll type inverse tangent, and I'll press equals, and that gives me 35.53. So I'd round that up, so I'm going to go ahead and say, again, we're going to the nearest degree, so I'm going to say that the measure of angle R equals 36 degrees, right? And so this is definitely one of the things we're looking for. I guess let me go back and show that we're looking for these as well. Okay. Now we could do the same method for angle Q, but remember we also know here that in a right triangle the acute angles are complementary, right? So what I can say here is that 90 degrees minus the measure of angle R is going to be equal to the measure of angle Q, right? So again, I mean, plug in what we have, right? We'd plug in 90 minus 36, and we could show that work, and we'd end up finding that the measure of angle Q is going to be 54 degrees, okay? If we're rounding, remember. So again, I'll say that the measure of angle Q equals 54 degrees, okay? And so now we have both of our angle measurements that we wanted. So maybe I'll write these in. I'll write this as 36 degrees, and this is 54 degrees. Okay, and now the last thing we actually want here is the length of segment RQ, right? And so we could find this out in a lot of ways. We could definitely use trig ratios, but remember it's kind of hard because we did use rounded values to find the measure of angle R and the measure of angle Q. So that way was a little bit more challenging. Okay, so instead I'd recommend just using the Pythagorean theorem, right? So we know that basically that PR squared plus, it's a bad square, but PQ squared is going to be equal to our hypotenuse here, which is RQ squared. Okay, at this point I know that PR squared is definitely just going to give us 49, right? So 7 squared is 49. I know that PQ squared here is going to give us 25, and that's going to be equal to RQ squared, right? Now we know that 49 plus 25 here. So again, I get 49 plus 25 gives us 74. So I got now 74 equals RQ squared. And now I'll take the square root of both sides, right? So the square root of 74 should actually give us our answer here, and it looks like it's going to be 8.60, okay? So I'll say that RQ equals 8.60, okay? And now we have 3 angle measures. So I guess we can maybe circle this one too. We have the measure of angle P as well at 90 degrees, and we have our 3 side lengths, and we've now solved this triangle. Okay. We could also use the distance formula for R to Q. That's why they went through it in the warm-up, so maybe we'll do that in the next example. But again, it's important that we're able to use trig ratios, okay, and also their inverses to find the angle measures.